In Python, true and 1 are equal, and then also false and 0 are equal to each other. So if I run this command here, you can see that we have just printed a tuple. By putting a comma in between these two, we can print them on the same line. So here you can see that we get the output true for is true equal to 1. We get the answer of true. Then we work out is false equal to 0. Then we also get the answer true. So this shows us that true and 1 behave the same. False and 0 behave the same. This matters in things like sets, which I will talk about later on. So why does this happen? Why is true equal to 1 and false equal to 0? So this is because the type for true and type for 1 are pretty much the same. So let's show you this. So if I run this command over here, you can see that the type for true is Boolean, type for 1 is int, and then using the special isInstance method, we're checking if true is of the class type int. Okay, so is the true value a class of int? So does it come from the original object, which was int, or the original class? So this is it. Bool is actually a subtype of int. So that's why we get the true answer here for is true in instance of int. So true is equal to 1 and false is equal to 0. So if we have a look at sets, how sets behave. So if I run this command, you can see that set is denoted by these two curly braces. If we put any duplicates in here, such as 1, 1, then that duplicate would get removed. So you end up with 1 and 2. So the two ones have been removed and converted into one of these, and then the number 2 is by itself. So this becomes interesting and important to understand. Equality matters. So what do I mean by that is, this one over here is equal to this one. So when they are equal to each other, then only one of them is kept, duplicate is removed. So in the same instance, when we do it on a Boolean and a 1, then what we end up with is just the value of true. This is because true and 1 are equal to each other. Then don't consider them to be the same. They are actually equal to each other. So that's important. Equality matters. So true and 1 are the same. So here, as we saw, true is equal to 1, so only 1 is kept. Set only keeps only one of them. So here set removes the 1 and keeps the true. And same with this one, it keeps the 1 and removes the true. This is because the order matters. Because we said this is true first over here, then it keeps true. Because we said 1 over here, it keeps the 1. And the same logic would apply to false as well. False is equal to 0. So only one value is kept in a set. So false again is equal to 0. Same duplication rule applies. So that's why sets remove the duplicate false and 0 and just keep 1. Again, false appears here because false is the first value. So when it spots the next value, it just removes that. The other thing you can do is you can do some Boolean math, which is very useful. So it enables counting logic and can be used in conditions. So here, for example, if you add true plus false, then if I run this will give you an answer of 2. So that's 1 plus 1. Think of it like this: 1, 1 plus 1 plus 0 is equal to 2. So it enables some Boolean math and also enables some counting logic. So you can essentially count all the ones, and then that would say the count is 2. And the 0 would not be counted. So just remember, true is equal to 1 and false is equal to 0. In Python, you can create the new set by using the set constructor. This is what the set constructor looks like. So if I run this command here, you can see that we get an empty set. Now, as a beginner, you might think that a set is these curly braces. So if I run this over here, you think you have created an empty set. This is not right. So this value over here is incorrect. The right way to do this is via the set constructor. What this has done is created a dictionary. And I can prove that by going down here. And if I run this line over here, you can see that this is a dictionary. So that's why you need the set operator. So this answers the question, why is set constructor needed? Because it actually creates the set type. Now, again, we can prove that by running this command over here, and you can see the type of the class for this one is set over here. While for the curly parentheses or the curly braces, it's dictionary. So these curly braces create a dictionary and do not make an empty set. So as a beginner, do not do this and expect to have a set. So here we have numbers variable, and this number variable contains a list. The reason this is a list is because of these square brackets. So we can tell this is a list. Lists can contain duplicates. So this is a valid statement that you can see here. There's a duplicate of 2s and 3s. So in order to remove the duplicates, what you can do is you can use the set command over here, and this this removes duplicates. So set removes duplicates. So if I run this code over here, you can see over here that duplicates have been removed. We are now left with 1 over here, 2's only 1, 2, and 1, 3. So you end up with 1, 2, 3. So duplicates have been removed by simply using the set constructor and passing it the list of numbers that we had where we had duplicates. So remember that set contained unique values only. Original list, it unchanged. So this list still remains and hasn't been changed, and the duplicates disappear. So here, when a new set was created, duplicates have disappeared. You can easily assign this to a variable. So if I were to assign this to a variable, so here I've coordinated my set. So if I run this over here, and then we can print both. So if I print numbers first, you can see that's intact, still has duplicates. But if I print my sets, so if I replace that there, you can see that in the set one, duplicates are removed. And notice the curly braces. Just don't get confused with curly braces over dictionary, which is different to a set. This is a super useful tip that you want to be aware of. How do you create a set from a string and remove duplicates? So here, what you can see is we have a string called banana. And here, this is the set constructor. Now, what I want you to think about this string over here, think of them as individual characters. So strings are iterable in Python. So what we mean by iterable are that you can work on them one by one, like in a list. So think of them as like array items. So you just get given each letter separately, so you can loop through it. So that's why set can work on iterable items. So here, that string is iterable. Each character becomes an element. So as I said before, all these characters become a single element. So if I run this code over here now, and what we can see is we gave it the string of banana, but all the duplicates have been removed. So duplicate letters are removed. Or I want you to think about duplicate elements are removed because each character is considered an element. So here, as they went through B, there's only one B, so it's kept that. There is 3 A's here, so you have 3 A's and only one of them is kept. And there are 2 N's here and only one of them is kept. So what has essentially happened is repeated characters in the string banana have been removed by using the set constructor. So we only end up with unique characters. The set constructor is really useful to remove duplicates, and in this instance, it's very useful for removing duplicates from a string. Let's see how we access items in a set. So here you can see that I have created a set with the following colors. So these are the strings, red, blue, and green. This is the variable name. The set is indicated by these curly braces or parentheses. And here, by typing in the colors variable, I'm just going to print them. So the last statement is always printed in Jupyter notebooks. If I run this over here, you can see that we've got the output blue, green, and red. What I want you to notice is that the order is not matching what I typed in. So here, I typed in red, blue, and green. But the output that I got is blue first, which is the middle element over here. And then I've got green, which is the last element. And then I've got red, which is the first element. So there is no guarantee that the order you put in is the order you will get out in a set. And this is a normal behavior for sets. So you just need to get comfortable with the fact that what you put in that order, you probably will not get it in the same order. Next, we will look at accessing an element. So here, this code here, it looks very familiar. Some of you may have come across arrays and so on. So we are accessing using this subscript or index number. So if I run this, what you will get is an error. The error says the set object is not subscriptable. So this syntax raises an error. So you cannot do that with sets. So anything that's in these curly braces separated by commas. Please do not confuse this with a dictionary. Dictionary is different to a set. So this error actually shows us here that sets have no positions. That also explains why we've got this random order versus what we actually put in. So one of the main ways you can access set elements is by using a for loop. So use the keyword for over here, and then you create a variable here, just call it whatever you want, versus the original variable that we have. So here we have the colors variable, and that's the variable that I have used over here. And then I'm going to print the individual color, so each element within the set. So if I run this over here, you can see they output we got is blue, red, and green. So we used a loop, and this is the main way to access items in a set. So for each color in colors. So this loop will access one item at a time. Order is not guaranteed. So this is the important bit. So you can see here the order we got is blue, red, and green. So the first element, so let me just clear these outputs so we can see it. So here you can see the element we got first is blue, but blue is the middle element. Then we've got red, which is the first element, and then we've got the green last, which matches the original. But there is no guarantee, and that's what you need to be aware of. So use a for loop to access elements in a set like this, and it will print out each element for you in that fashion, or you can do any further processing with it. How do you check for elements that exist within a set? So in this video, I will show you this. So here we have a set with the following 3 elements. This is the variable name. So I will run the statement, and you can see it now has the 3 elements that we specified. Now, one way you could do it is by running a for loop, but by running the for loop, you can then add a statement here, or in this case, I printed them. So I can check, actually red color exists in my colors variable over here, which is made up of this set. But the other easier method you can do is you can use the in keyword over here. So here you can see that I am using if blue in the variable colors. So the variable colors has the following elements. So is blue one of the elements that's been specified over here. So when I run this, you can see that it returns true. So the in statement will always return true or false. That's all it will do. It does not give back the original value to you. So here it does not tell you actually blue as the value, instead just returns true or false. So here you can check if yellow exists, and you can see yellow is not an element in colors, so we get a false, whereas for blue we got a true. If we look, we don't have yellow in our list. So the in statement checks for membership, not position. And what you need to remember is sets have no positions. So it's very simple. Just use the in keyword, the element you're looking for in which variable. Or the alternative is you can loop through it, add a condition to check if the element exists. But you can see this is much better than doing a loop, although the loop does give you back the element, which the in statement does not. So you have 2 ways of safely checking for items in a set. One is the loop, and the other is the in keyword. Let me show you how the pop method works in Python, especially for sets. So here I have a set with the following colors, and you can see the order I put the colors in is not the order that they appear in the output. So they are unordered. That's an important thing to be aware of for sets. What you put in, for example, red there, but the first element is actually blue. Then I've got blue, but actually the second element is green. But remember, although I'm saying second element, first element, there is no order to sets. That's an important concept. So when you do a pop, you won't necessarily know which item it's going to remove. So you can use the variable name and the pop command for the pop function over here, when this will remove an item. So pop will remove one item for you. So if I run this, you can see here that one element has been removed and green and red remain. So blue has gone, and now we only have green and red remaining in our colors variable over here. And notice this is still a set. So this element over here does not, the original variable does not change. Now, one thing you may notice is, why did I put a variable here? Because the pop method will actually return which item has been removed. So it returns the item that has been removed. So if we run this over here, and you can see that the item that was removed is blue, which is what we expected because we only have green and red left in the set now, whereas previously we had blue. But one thing you will notice with this pop method is you do not specify which item gets removed. So you do not choose which one gets removed, and you don't control which items come out. Although this may look very ordered, but do not rely on this order, because as you can see, what I put in versus what I got out is completely different. So if you have thousands and millions of elements or in your set, then you cannot rely on the pop method removing it in that specific order. Plus, you won't actually, with thousands and millions of elements or hundreds and thousands of elements, you won't necessarily remember the order. So there's no point in relying on any order. Sets are unordered. But in this way, you can see the removed item, and then you can do something with it. Today, I'm going to show you sets and why you can't access the index. So if you need to access the index, then you need to convert it to a list. So here you can see I have a set, and the set is denoted by these 2 curly braces and is comma separated. So do not confuse this with a dictionary. Dictionary will have a colon in it, while sets will only have the curly braces over here and is comma separated. So you cannot do indexing with sets. So if I try and run this code over here, what you'll see is you'll get an error to say that this code command is not allowed. So you cannot do this. Set object is not subscriptable. So what you need to do is convert a set into a list. So you can convert it using the list method over here. So list has a constructor. So this is the list constructor. So you name the class of the list, and then in the open parentheses, you put the variable or the data type that you want to convert. So in this instance, this variable is, you can see that it's a set that we want to convert, and this will give you or return to you a color list. So whereas this is a set and you cannot do this with it, with a list, you can do that. So you can do indexing. So if I run this code over here, you can see that the first item here, color list, had worked, and the first item is blue. Whereas in a set, it didn't work. So if you had a set like this will not work. While with a list, indexing is allowed and works. So after you've converted it, you can use the indexes in this fashion. But one thing I want you to be aware of, that the order is still arbitrary. As we know with sets, the order cannot be relied upon. So here, for example, I put the first item as red, but in the output, we see the first item as blue. So here you can see that the first element is blue. But if I were to restart the kernel, so if I click on restart over here and click restart and then run this exact same code again. So if I run this, and notice here at the minute, this is blue. So now I will run this again, and this blue will probably change. So if I run this, and you can see that this has now changed to green, where the first element in here is blue, and how I originally put it in is red. So this is one of the things you need to be aware of with sets. So just a few important reminders then. If you really want indexing, convert the set into a list. So if you really want to do this, then you have to do this, and this will let you do indexing. But it is important to understand that the order isn't meaningful. So this is an important point. So as you saw here, we've got a different order versus what's actually in the set versus what we actually input originally into our set. So this completes another knowledge block for you on your journey to learning machine learning in Python. In this video, let's learn about the remove method and what it actually does. So here I have a set and I want to remove a few items from it. So first of all, let's create the set. So remember, set is denoted with these curly braces or curly brackets. And here, this variable is going to store that data. And then I'm going to just simply print that data. Remember, in Python Jupyter, you print the data by just inputting the last expression and it will display in the output. So if I do that, you can see in the output, I got the following items in my set. So in order to remove the items, I can just use the remove method and pass in the value that I want to remove. So in this case, I want to remove the number 2. So this isn't the position number 2. This is the actual value 2 that I want to remove. So if I run this over here, you can see that we removed number 2 from it, and then we reprinted the numbers variable, which is a set. So originally it had 3 elements in it. Now it's got 2 elements in it, and I can remove another item. So if I do remove again, if I now do the number 3 and let's run this, and now you can see that the only number that remains is the number 1. But if I try and remove an element that doesn't exist, then it will cause an error. So 5 didn't exist in our original list over here. So what will happen is it will cause an error. So if I run this, you can see that we have an error to say key error 5. So sets are based on keys. Essentially, your values in here become keys. Think of them like primary keys in a database. And if it cannot find them, then you will get this key error. So the remove method can accept a value that has to be a key and must exist in your set. So for example, 2 existed for us, so it worked, but 5 didn't. So what it did was it raised key error. And that's why you see the key error over here to say that it's missing. 5 does not exist. The reason 2 and 3 worked is because they existed. So if the key exists, then you will not get an error and the item would be successfully removed. The key error will actually stop your program from working. So here it has actually caused a failure. So you can see there's a failure and it stops your program from working. The error will show up immediately in your code. So if you have a production level code, then you will see the error pop up. But remember, this error is actually by design. So the actual crash happening might be useful, especially when you are checking for missing data that should never. Then this error actually is quite useful and it will make you realize that something have gone wrong. So rather than basically not throwing up the error, it might actually cause more problems, especially if you are looking at missing data. So in this case, the error is a good thing. It's a positive thing. Let's understand the discard method versus the remove method. So both methods are very important in Python, especially for sets. So let's begin at the top. So here we have a set with the following numbers. So if I run this code here, you can see we put a set that contained the following numbers. If we remove an item from a set, then it gets removed. So we remove number 2 from the set and it removed fine, no issues. But if we try and remove an item that does not exist, if I run this over here, you will see that we get a key error to say this item does not exist. And this is where the discard method comes in. So this discard method works pretty much the same. So if we run this here, you can see we created a set using these curly parentheses or braces, and then we decided to remove number 2 and then reprint the list. So here you can see that we have now removed number 2, and that's fine. This worked fine for the remove method too. So the remove method did the same thing. But if we have a look at try removing 5 here, which did not exist in our list, so 5 does not exist. With the remove method, you can see that we've got a key error to say, 5 doesn't exist. But here, if we try and remove 5, you will see that we do not get any errors. So 5 being missing didn't cause any errors. So to use the discard method is pretty much same syntax as the remove method. All you do is just use the method function name remove and then supply it a value, and that will work. But the main important difference is you get no error if something is missing. So discard removes item only if they exist. So 5 didn't exist, so it didn't show up any error. But since 2 existed, then it removed 2. When an item is missing, like 5, the code just continues to run. So you will have no issues, and then the second line is printed. While here, you can see with the remove method, the second line never gets printed. There's nothing in the output here. It just says key error and nothing else is done. So remove will cause an error if missing. Discard will display no error, as we saw in the example over here and with the remove method over here. So to wrap up, when should you use it? So you should use the remove method when an item must exist and you want to know that there's an error. So here we wanted to, for example, with the remove method, let's say we wanted to ensure 5 must exist. If it doesn't, then tell us about it, basically show an error, then this would work. But with the discard method, if the item is missing, it's okay. We don't care. We just want the code to continue. So here 5 is missing and code just continues. We don't care about it basically. So just remember this tip. Remove is if you want to check and make sure the item gets removed and it must exist. Discard if you don't care and you go, you know what, that's fine. If it doesn't exist, let's just continue.